Topic 1-3, adding and subtracting integers. If you have some algebra tiles, you can ask your teacher for some, or you actually can just draw little boxes on your page. But if you want to look at it, an easier way of memorizing rules, you can use the algebra tiles. So I've done just a few examples of the ones that are on your note page, and actually I just picked the ones that are addition, so we're going to have to go through some subtraction in a minute. But look at the first one. If you're using algebra tiles and you lay them all in positives, you've got two positives and four positives. So of course we know that that's equal to 6. All right, another example would be if you have 4 positives, shown here, and 3 negatives. Well, here's how algebra tiles work. What you do is you look at pairs. Positives and negatives cancel each other out. So as you see pairs, cancel them. There's a positive and a negative and a positive and a negative. See, what you're left over with would just be a positive 1. So 4 plus a negative 3 is just positive 1. Here I've set up 2 positives and 5 negatives, canceling out a positive negative, a positive negative. What are you left with? Negative 3. The last one of this example, negative 4 plus a negative 1. So I've put 1 here and 4 next to it. There's nothing that can be canceled out, so you add up all of the negative tiles. So this one would be negative 5. So if you find adding and subtracting integers easier using algebra tiles, ask your teacher for some, but I'm going to do a couple of examples without showing tiles. We'll actually just draw in the colors. Yellows for positives and reds for negatives. Okay, oops. So let's go to the rules of the integers. Sometimes this gets confusing for students, so just bear with a couple of examples if you're still struggling with adding and subtracting integers. If you have two numbers that have the same sign, either a 4 plus 3, those would be considered two of the same sign, so that would be 7. If you have two of the same signs which are negative, like a negative 3 plus a negative 2, then you're going to keep the common sign and just add. So this one ended up being 7, and this would be a negative 5. Because you're adding two negatives, you keep the sign and continue it with a negative. Okay, if they're different signs, you're going to subtract the numbers, whatever number it is, but then you're going to keep the sign of the larger number. An example of this would be having something like a negative 3 plus a positive 2. The numbers have different signs, so if the signs are different, then you're going to ignore this negative in front and subtract. So that would be, you're going to get a 1 when you subtract 2 from 3. Keeping the larger sign of the larger number is actually denoted with this, being 3 is your larger number, so the sign is going to be negative. But that's just looking at the rules and not using an algebra tile. Again, if you're subtracting integers, you're going to change to an addition and add the opposite. The rule may sound a little confusing, but let's use that same number, a negative 3 minus a positive 2. What they mean by changing to addition here, I'll do it with a different color, is they mean this. Change this to a positive and make the sign its opposite. Then you're just looking at two, like the first example, that have a common sign, so you're going to just be adding those two together and keeping the sign, so that would be a negative 5. Okay, let's do a couple of examples, and I'm going to just make some squares like the top that we did the algebra tiles. If you have -4, well, our negatives were used, we were using red, so I'll just put 4 negatives. Oops, kind of make those a little bigger. And then we actually have 8 positive. They're not always all going to be the same size. I'm going to put one out there. Okay, so again, you're looking at canceling out. If I have 4 negative tiles and 8 positive tiles, you're canceling out positives and negatives, pairs. What are you left with? The yellow meant negative, so positive, so you end up with a positive 4 being your answer. So if this helps, just draw some pluses and minuses on your paper to figure out when the signs, especially when the signs are opposite. So if the signs are opposite, like this example, then drawing the algebra tiles would be helpful. This, however, the signs are common, so you're just going to continue with addition and keep the sign. So this would be -16. Okay, the next page. There are 15 more problems. I'm just going to do the even numbers, and I'm going to let you either use your algebra tiles or your rules from page 1 to answer the odd numbers for these notes. So let's look at number 4. If you've got 0 minus 6, if you want to think about the rule, then you're looking at taking, let's change colors here. I'll do it in blue. Okay, 0 minus 6. Because this is a negative, we're going to change it to a positive and then change the second number to its opposite. So you're really adding 0 and a -6. So 0 and a -6 would just be equal to a -6. Alright, so the next one, you're looking at, I'm going to do number 6, is also a negative. So we're going to change the sign to a positive, make the second number its opposite, which is negative, and then you're just taking the operation and subtraction because the signs are different. You're subtracting 7 from 25, which gives you 18. Then you're just taking the sign of the larger number, which the larger number in this case is the 25. So what is the sign that the 25 had? Negative. Okay? Again, just back it up and listen to it again if you feel you need some extra help with that, because this next one has both an opposite, a negative and an opposite. So -6 minus a -10, you change to a plus sign. You're going to also make this 10 its opposite. Since it was a negative, now we're going to make it a positive. Okay, so again, the signs are different. So we're going to take the sign of the larger number, which is positive, but we're actually subtracting 6 and 10. So you're ignoring the signs when you do that. You ignore the positive here and the negative here. You just think of subtraction and taking the sign of the number that I circled. Oops. Okay, number 10. You've got just addition going across here. So you're just adding. There's no thinking about subtraction on this. 11.8 is what you would get when you add these two, and adding that to 8.7 gives you 20.5. And a lot of times, you know, the rule is you can actually use a calculator to do order of operation. You just have to be careful with fractions and any division bars. I think I'm going to skip 12. I'll let you all work that one on your own too. Look at number 14. We're going back to remembering what we did with absolute value. So we have to look at what's in this absolute value inside these bars of our absolute value first. So the first thing we're going to do is notice it's subtraction. So we're going to change the sign to a positive and make it its opposite. This one's okay because it's already addition. So ignore what's on the outside of these absolute values first, because right now we're just looking for what the answers to inside these absolute value bars are. I'm going to go ahead and put this down again. Okay. So -7 plus -5. They both have the same sign, so we're just going to add those together. 7 and 5 is in the negative mode is -12. -2 and a +1, because the signs are opposite, we're going to subtract and we're going to take the sign of the larger number. So this is actually going to be a -1. Notice inside your absolute value bars, which now we've drawn down here and here, they're both negatives. So what happens is this actually becomes a +12 and this actually becomes a +1. And if you think about this now, I'm going to put parentheses around these because there is something to do from the outside. This is a -1 and this is a -3. And what we need to do with these is to multiply. This is understood to be a -1 right here. Anytime you have a negative with a number next to it, it's like multiplying -1 times a +12. So this is actually -1 and 12 gives you a -12, and a -3 times a +1 is also a -3. Here is subtraction of opposites, so we have to remember that we're going to add the opposites. Let's show that with the add a negative. And because both the signs are the same, this ends up being, put this in blank, this ends up being keeping the sign and just adding. So that's -15. Again, you can use the algebra tiles for the whole numbers, and come ask me if you need some more help.